an atom has too many neutrons in its nucleus, it is unstable. In this situation, the nucleus will undergo beta decay. And there are actually 3 different types of beta decay. The original type is represented by the Greek letter beta with a negative superscript. This negative superscript represents the electron that is ejected from the nucleus of the atom when it undergoes beta decay. Now, hopefully about now you are a bit confused as to how an electron could be thrown out of the nucleus when you know that electrons are not found in the nucleus. Well, it turns out that neutrons are not stable. Neutrons themselves will decay. We can examine this a little bit more by looking at what might make up a neutron and treating it in the same way we treat atoms when they decay. A neutron has a neutral charge, so when it decays, it must decay into things that have a net charge of 0. When a neutron decays, it actually decays into a proton and an electron. The proton stays behind in the nucleus, and the electron is ejected from the nucleus. Since the electron that forms inside the nucleus is not one that orbits the nucleus itself, we give it the special designation of the beta electron in our decay equation. Now, the short history of beta decay is pretty interesting. It was originally defined in the early 1900s along with other types of decay. A couple decades later, we were able to take some more accurate measurements, and it became apparent that all kinds of conservation laws were being violated in this type of reaction. Energy, angular momentum, and linear momentum were not adding up between the neutron decaying into a proton and electron. It was then that a new particle called a neutrino was proposed. The reason this particle was so difficult to detect was because not only does it have a neutral electric charge, it also has an extremely small mass. It's actually so small that we can ignore it in our calculations. So really what happens is the neutron decays into a proton, a beta electron, and a neutrino. So we start out with some element X that has A as the mass number and Z as the atomic number. When the neutron decays into a proton, the atomic number will increase by 1, creating a new element Y. The mass number is the total number of protons and neutrons, so it will stay the same since we lose 1 neutron and then gain back 1 proton. Our final products of the decay equation are an element with 1 more proton than our original, a beta electron that is ejected from the atom, and a neutrino. Say we have carbon-14 undergoing beta decay. The mass number of carbon-14 is 14, so it starts out with 6 protons and 8 neutrons. One of those neutrons will decay to a proton and a beta electron. So carbon-14, it used to have 8 neutrons, and now it has 7. It also used to have 6 protons, but now it has 7. So when the neutron decays, it gains a proton, which makes it a new element that has an atomic number of 7. Looking on the periodic table, we see that the element with an atomic number of 7 is nitrogen. Now, if we add up the number of protons and neutrons, we still have a mass number of 14. Then, of course, we do not want to forget about the beta electron or the neutrino. The second type of beta decay is called positron decay. This is not as common, but occurs when there are too many protons and not enough neutrons in the nucleus of an atom. A positron is essentially the opposite of an electron. The mass, size, everything about a positron is the same as an electron, except that it has a positive charge instead of a negative charge. A positron is an example of what we call antimatter. The symbol that we use for a positron is a capital beta, just like for our beta electron, but we give it a positive charge symbol. The decay equation for positron decay is very similar to that of regular beta decay. We start with some element X that has a mass number of A, and Z is the atomic number. When the proton decays into a neutron, the atomic number will decrease by 1, creating the new element Y. The mass number is the total number of protons and neutrons, so it will stay the same since we lose 1 proton and gain 1 neutron. Our final products of the decay equation are an element with 1 less proton than our original, a positron, and a neutrino. So say we have carbon-11 that will undergo positron decay. The mass number of carbon-11 is 11, so it starts out with 6 protons and 5 neutrons. One of those protons will decay into a neutron and a positron. So carbon-11 used to have 5 neutrons and now it has 6. It used to have 6 protons, but now it has 5. So when the neutron decays, it loses a proton, which makes it a new element that has an atomic number of 5. We can look on our periodic table and we can see that the element with an atomic number of 5 is boron. Now if we add up the number of protons and neutrons, we still have a mass number of 11. Then of course we have our positron and our neutrino. The third type of beta decay is called electron capture. This occurs when there are too many protons in the nucleus and not enough neutrons. In this process, the nucleus of the atom actually captures one of the inner electrons that are orbiting the nucleus. When this happens, the electron will combine with a proton to produce a neutron and a neutrino. When an inner electron is captured by the nucleus, it creates an unoccupied quantum state. This allows one of the outer electrons to move to the lower energy level, and this movement to a lower energy level releases energy. So start out with element X, has a mass number of A and an atomic number of Z. When the proton captures the electron and becomes a neutron, the atomic number will decrease by 1, creating the new element Y. The mass number is the total number of protons and neutrons, so it will stay the same since we lose one proton and then gain one neutron. Our final products of the decay equation are an element with one less proton than our original and our neutrino. So say we have beryllium-7 that will undergo electron capture. The mass number of beryllium-7 is 7, so it starts out with 4 protons and 3 neutrons. One of those protons will capture an electron and convert itself into a neutron. So beryllium-7 used to have 3 neutrons and now it has 4. It also used to have 4 protons, but now it has 3. So when the neutron decays, it loses a proton, which makes it a new element that has an atomic number of 3. Atomic number 3 is lithium, and if we add up the number of protons and neutrons, we still have a mass number of 7, and then our neutrino.